Alright, it's John here again, and I got a comment from Ed Mathis that I should look into Doc Memoize. And the comment was that Rich Hickey thought of everything. So let's run Doc Memoize, and we see that we have a function that returns a memoized version of a referentially transparent function. The memoized version of the function keeps a cache of the mapping from arguments to results, and when calls with the same arguments are repeated often, has higher performance at the expense of higher memory use. So that is exactly what we do. And if we jump in and look at the definition of memoize, we see it takes in a function, makes an atom with an empty map called mem, tries to find the value stored under that. So basically does what we had injected into our solution, except in a much more elegant way. So let's try it out. So let's define our Fibonacci function again. We'll give it a parameter n, and if n is less than 3, we're going to just return n. Otherwise, we are going to add the Fibonacci number from the one before, the previous Fibonacci number, so n minus 1, and also the Fibonacci number n minus 2. Okay, so pretty simple definition. We're back to the simple version. Too many arguments. We want to define a function, right? Defin. Okay, so now we have fib. We'll test it out. Map fib over the range 1 to 11 again. And there we go. So we have our Fibonacci function working. So now what we can do is we can define a memoized version of that. So we'll call it memfib. And that is just memoize fib. Evaluate that. So now we can map memfib across the range 1 to 11. Oops. Range 1 to 11. And we still get the same answer. Let's make it a little bigger. Say 1 through 30. So okay, seems pretty fast. Maybe let's bump it up. Let's make it 40. Okay, so that took some time. We can actually measure that. So there's a time macro that we can run. That will run that and then tell us the time. Let's move this out of the way. Okay, so we can run the time macro on that and the time macro here. And we can see which one does better. Okay, so we run the time macro on our original version. Very fast, apparently. But our memoized version is a little bit faster. Took about half as long, and of course if we run it again, it got a little bit so fast you can't really tell. So let's go a little bigger. Can we do the range 1 to 50? Oh, yeah. I think we're not doing this the right way. We need to do all. Map is a lazy. Returns a lazy sequence, so we don't want to do it like that. Let's just kill that. Let's go back to 40. Let's start over here. Get our ripple going again. Okay. Define our function. The memoized version. One more time. Do all on our map. There we go. So that's at 3 seconds. That seems more legitimate. And now with our memoized version, 0.02 seconds. So yeah, once again, we didn't do all, so that was alright. Let's do this the right way. Let's make our function. Time it. And what does it take as a parameter? It's going to take a function parameter. And we'll just do it like this. Okay. Time to alright, so now we're not gonna map fib, we're gonna map f. Alright, here we go. So now we can do time it, and we can call it with fib, and then we can do time it and call it with fib, with memfib. Alright, let's just restart the rep. We'll get rid of all this state. Since now we're dealing with memoized functions, we've got some state involved. So let's evaluate this again. For our Fibonacci sequence, we have memoized version. We have a function to time it, so let's time it on fib. Okay, 2.7 seconds. Memoized. Just barely a little bit faster. Now we should see speed up the second time we run it because everything should be cached. So let's run it again. There we go. 0.15 seconds. Whereas if we call fib again, we're still up 2.2 seconds. It's just not getting any faster. Our memoized version is very fast. So we can run our time it. We want to take while our number is less than 4 million for e to the 6, 4.0 e to the 6. Time it. We want to filter out to just have the even ones. And we want to apply plus onto it. And what do we get? 4613.732. Great. So now with this one little command, memoize, we have a cache built into our function. So that is very elegant, and that is a great trick to know. So thank you to Eb Mathis for enlightening me on that. Thanks for watching.